Hello and welcome. Today we're going to dig into the hidden chemistry of metal. We're going to explore this incredible journey that takes it from raw earth to the sleek, finished products that literally build our world. It's a wild story of brute force and really delicate chemistry. And believe it or not, it's happening all around us all the time. So let's just start with a super simple question that really gets to the heart of it all. How does a rough, kind of worthless-looking piece of rock, like this bauxite ore here, turn into something you have in your kitchen right now, like aluminum foil? Well, the answer is all wrapped up in the science of metallurgy. Okay, first thing you have to understand is that valuable metals aren't just, lying around waiting to be picked up. Nope, they are chemically locked inside rocks in these things we call minerals. So the entire process, from start to finish, has to begin with finding and isolating these hidden treasures. Now, a mineral is really just a substance that occurs naturally and has metal in it, usually bonded with other elements like oxygen or sulfur. But here's the key part. Not all minerals are worth the effort. We only really care about the ones called ores. An ore is where the concentration of metal is high enough to actually make it profitable to go through all the trouble of getting it out. So when miners dig up this ore, it's mixed with a ton of useless stuff. We're talking dirt, sand, other rocks. This waste material actually has a name. It's called gangue. And that means the first big challenge is basically a giant sorting problem. How in the world do you separate the valuable ore from all of that worthless gangue? And that brings us to our first major step, concentrating the ore. The whole goal here is pretty simple. Get rid of as much of that gangue as we possibly can. Why? Because it makes all the next stages of the process way more efficient. And there are some really clever ways to do this. The method you choose all depends on the properties of the ore and the gangue. For instance, you could just use water to wash away the lighter junk in a process called hydraulic washing. Or you can use a bunch of froth to make certain ores float right to the surface. And if you're lucky and your ore is magnetic, you can just use magnets. Take a look at magnetic separation. It's a perfect example. What you see here is crushed ore getting dropped onto a conveyor belt. At the end of that belt, there's a magnetic roller. As the belt turns, the magnet just holds on to the magnetic ore particles for a split second longer, making them fall into a separate pile from all the non-magnetic waste. It's a surprisingly simple but super effective way to sort the good stuff out. All right, so once we have our concentrated ore, it is time to finally extract the metal. And this is where the real serious chemistry begins. And it usually involves, well, a trial by fire. The idea is to heat the ore and chemically convert it into a form that makes it way easier to isolate the crude metal that's hiding inside. Now, this stage often involves one of two key processes, roasting or calcination. They both use crazy intense heat, but there is one absolutely crucial difference, oxygen. Roasting adds a bunch of oxygen, which is perfect for converting sulfide ores. Calcination, on the other hand, happens in the absence of air, which works great for carbonate ores. But check this out. The end goal for both is exactly the same, to create a metal oxide. And that is the key. So now we've got our metal oxide, what's next? Smelting. This is when we heat that oxide with something called a reducing agent, which is usually carbon. You can think of the carbon as being a little thief that comes in and just steals the oxygen atoms away from the metal. And what's left behind? The crude, impure metal we've been after this whole time. And get this, in some cases, the ore can even reduce itself in a process called autoreduction. With copper, for example, the copper sulfide actually reacts with the copper oxide, and the result is pure metallic copper. Boom! This is that magic moment, the point where the metal we recognize finally emerges, ready for the last steps of its long journey. Now, the metal that comes out of that furnace is called crude for a reason. It's still not even close to pure enough for most uses. It's got other metals, some nonmetals, leftover ore, you name it. So it needs one last step, a final polish, which we call refining. And refining involves some very sophisticated chemistry. You've got different methods for different metals, but the goal is always the same, remove every last tiny impurity. This step is what lets us achieve those ultra-high purity levels that modern technology absolutely depends on. And that, my friends, brings us full circle, right back to our aluminum foil. After that whole long journey from rock to refined metal, we have a material that is so much more than just food wrap. Pure aluminum is lightweight, it's strong, it's corrosion resistant, and that makes it essential for everything from airplanes to medical equipment. All of that potential locked away in a humble red rock. Now, you might be thinking that this level of complex metallurgy is a pretty modern invention. But to wrap things up, I want to show you a stunning historical example that proves that is definitely not the case. For this, we're going to travel to Delhi, India, to see a true marvel of ancient science. This is the Iron Pillar of Delhi. And what's so incredible about it is its age. It has been standing right there, exposed to the rain, the sun, everything, for over 1,600 years. So what, right? It's an old iron pillar. What's the big deal? I mean, we have ancient structures all over the place. But there's something about this one, something completely unique that has baffled scientists for centuries. Here it is. Here's the mystery. Any normal piece of iron left outside for 1,600 years should have corroded into a pile of reddish dust a long, long time ago. But this pillar, it stands almost completely rust-free. How is that even possible? Well, the answer is a straight-up chemical masterpiece. The ancient Indian metallurgists who made this created a unique iron alloy. Over many, many years, a super-thin protective film of a compound called misawite formed on its surface. This corrosion-resistant layer, which is just fractions of a millimeter thick, has shielded the iron from rust for 16 centuries. It's a testament to their incredible, mind-boggling skill. So from a rock transformed into foil to an ancient pillar that basically defies time, the story of metal is really a story of chemistry. And it kind of makes you wonder, doesn't it? What other hidden scientific journeys are locked away in the everyday objects all around you right now?